Next up, factors, roots, and zeros. 3 different ways of talking about the same sort of idea. Here's the analogy, though, that I want you to keep in mind. The roots of a polynomial, which we'll also sometimes call the zeros, which are related to the factors, are the DNA of the polynomial. Here's what I mean. If you know a polynomial's roots, you know pretty much everything about the entire thing. It's very essential to the core structure of that overall polynomial. Here's what I mean. Take this. I'd like you to graph it. Actually do this. Pull up your Desmos or your TI and graph this. Pick a number you like for A, and I want you to see what it looks like. Then pick a different number for A. See what it looks like. And then we'll reconvene here to discuss in just a little bit. For all of your graphs, I want you to make a note of what the x-intercepts are. Okay, I hope you've already played around with it a little bit. If you haven't, do that now. I actually set up a slider here so that I can look at lots of different values of this A. But notice that there are some things that don't change. I asked you to keep track of the x-intercepts, and the x-intercepts are the same number all the time. There's one at -2, there's another at 3. And they don't move. All the A does is either flip your parabola up and down, depending on the sign. Positive A, parabola opens up. Negative A, parabola opens down. And then the bigger in size your A is, the more your parabola is stretched. That's all that the A does. It does not change where the x-intercepts are. It's for this reason that the x-intercepts, the zeros, are called the roots of the polynomial, kind of like the point on the x-axis from which the graph grows. If it always goes through those points, it's always coming out of those points. And here's the deal. If you look in the factored form of a polynomial, and that's what this was, when you have different powers of x listed in parentheses, that's the factored form. It lets you see the roots, which are also called the x-intercepts, which are also called the zeros, and we'll use all 3 of those terms interchangeably, of the polynomial. And if you know the roots, then you know a whole lot about how this polynomial is going to work. So up here, notice that the factors don't straight up tell you what the roots are. You need to think for yourself. Just like when you were solving quadratic equations, you've got to say, all right, if x plus 2 is a factor, what would make this factor be 0? Well, that happens when x is -2. There's your root. So this factor leads to this root. If x minus 3 is 0, well, then add the 3 over. X is 3. This factor leads to this root. So notice that relationship, how if the factor has a plus, the root's negative. If the factor has a minus, the root's positive. That shouldn't be new. We did that when we were solving quadratics, but something to keep in mind. What you're going to be asked to do is, given a polynomial in factored form, to find what the roots are. So please don't overcomplicate it. Here I'm giving you a polynomial. It's in factored form. I would like you to find all of the roots. There should be 4 of them. So quick pause, unpause when you're ready to check. So I say there are 4 of them because there are 4 factors. Even though this front x isn't in parentheses, it's multiplied by the other stuff and is therefore a factor. So we have 4 factors and therefore 4 roots. Now while we're here, let's just think for a moment. I'm not asking you to do this, but imagine if you multiplied all of this together. I want to know what the degree would be and what the leading coefficient would be. So just imagine multiplying all of this out. We'd have this front x times this 3x times this x times this x. Look just at that. If I multiplied just the front parts of all these factors, I'd have 3x to the 4th. Now, the other stuff still matters, but just by looking at the front parts of all the factors and multiplying those out, you can know what the degree is, you can know what the leading coefficient is going to be, and that then lets you determine the end behavior as well. So you can tell a lot about a polynomial here from its factors. Back to the task at hand. What you then do is you take each of these factors on their own and set them equal to 0. And x minus 1 equals 0. All right, this one's already done. This one, I hope, is fairly easy to do in your head, as is this one. So we've got 3 roots so far. And now this one, I'm actually going to encourage you not to try and do this in your head, only because I've seen so many good students make simple mistakes. You subtract the 1 and then divide by the 3. So this is actually a fractional root at x equals negative 1/3. So here's what you'll find. If you graph this, this is going to cross the x-axis 4 times. Once at 0, once at negative 1/3, once at negative 1, and once at positive 1. Those are the roots, the x-intercepts, the zeros of this polynomial function. It's one of the nice things, actually. If you're ever not sure if you've done it right, just graph it, and then make sure that you cross the x-axis where you think you do. Okay, let's look at the second one here. Same idea. I've got 1, 2, ooh. Now this is a little sneaky. I'm going to get 1 root from here at x equals 0. I'm going to get 1 root from here at x equals negative 2. But from here, notice that this isn't a linear factor, meaning it's got an exponent in there that isn't 1. If your exponent is 1, you get 1 root. If your exponent is 2, you're probably going to get 2 roots. And the way to get there is with the quadratic formula. So I really want to know what makes this 2x squared plus 10x plus 3 equal to 0. Okay, it's already in my standard form. So my x's are opposite of b, plus or minus, square root, b squared, minus 4 times a times c. So 4 times 2 times 3, which is 24, all over 2 times a. Now, I would like you to simplify this as much as possible. So let's do that. I'm going to pull up my handy-dandy calculator machine for 100 minus 24. Okay, so that's 76. So this is equal to negative 10 plus or minus square root of 76 over 4. When it comes to power assignment, this is going to be counted as correct. However, I'm speaking now to those of you that want to know how to do this algebra stuff a little better. It's not simplified. And if you check the answer key on the practice, it's not going to say this. It's going to give you the simplified version. So let's take now a moment, simplify this square root, and then see what the overall reduced answer should be. So let's think to the side here for a moment. This is just us thinking to the side about how to simplify this square root. 76 divides evenly by 4. So if I wanted to, which I do, I can write 76 as 4 times 19. The reason I do that is that the square root of 4 actually comes out to a nice whole number. Square root of 76 is the same thing as 2 square roots of 19. Just going to double check that real quick. So square root of 76 gives me this decimal. 2 times the square root of 19 gives us the exact same decimal. The reason we refer to the simplified version as simplified is because the numbers are smaller. It's easier to work with. So with that in mind, let's head back over here. I'm going to leave the negative 10 alone, but I'm going to write square root of 76 as 2 square roots of 19. Now take a look at what's happening up here on the top now. The 10 is even, and the 2 is even. So to simplify this, to get the answer that's going to show up on your practice sheet, I can factor a 2 out of everything. So all I did was look at the GCF of the 10 and the 2, which is 2, and then divide it out of those 2 terms. The reason we do that is that now I can reduce this 2 with this 4, factor on the top with factor on the bottom, and my final 2 roots end up being negative 5, plus and minus. Ooh, I'm going to make that plus and minus again. square root of 19 all over 2. So tell you what, I'm going to highlight final answers here just to make them easy to see. So we had 1 root from the x, 1 root from the x plus 2, and then because this was a quadratic, we got 2 more roots from that quadratic. -5 plus root 19 over 2, and -5 minus root 19 over 2. So in summary, thanks for sticking with me here. The factors set equal to 0 can help you find what the roots of the polynomial are. Those are the x-intercepts of the graph, and your graph goes through all of those x-intercepts. So if you know where those are, if you can find the roots, you know pretty much everything you need to know about that polynomial.